Okay, the following is a video over 3.1 notes, and this is introducing the derivative. In the last video, we talked about how we turned the secant line into the tangent line. And what I want to do is use some function notation and show you what happens as a result of doing that. So let's just take a look for a second. And I just want to draw a generic graph. I'm going to call this the x-axis and call this the y-axis. And I've got some function here that we'll call f of x, okay? And so what I'm going to do here is I'm going to call this a random x value, just x, okay? And if I find its corresponding y value, I plug x into my function and I just get the y value f of x, okay? So this is the point x and the y value f of x. Now, if I were to come over here, I don't want to go that far, and draw a line here, and put a point here, and let's say that I create some distance h, okay, just like we had in the last video, okay? I have this distance h is a distance, so consequently I have that this x value is called x plus h, okay? That's the distance x plus the distance h. All right, and if I found this corresponding y value, then I would just call this f of x plus h, okay? So if I wanted to find, say, the slope of this line between these 2 points, okay, and I'm going to call this the slope of the secant line, all right, then what I would do is I would just take, find the difference of my y values, which is f of x plus h minus f of x all over x plus h minus x. Okay, and so then this ends up giving me this, which is f of x plus h minus f of x all over h. Okay, because x minus x, these cancel out, and so you're just left with this. Now this will generate the slope of your secant line given whatever h is. Okay, remember h is a distance. H is a distance. Okay, and so this may look familiar to you. Okay, this is what you learned in pre-calc. This is your difference quotient. Difference quotient. Okay, and this is just another way for you to write the average rate of change. Okay, so this is what we've been talking about in 2.1. But remember, what we're trying to do is we're trying to figure out a way to find the slope of the tangent line here at x. Okay, and so what we found out is that if we found the slope of this tangent line right here, then if we moved h, if we shrunk h and had h approach 0, then this point would somehow get really, really, really close to this point, infinitely close, so that it eventually will just turn into the tangent line. And that's what we watched in the first video. So if you have no idea what I'm talking about, this is the same thing that I was talking about in the other video. So you need to watch part 1. Okay, if you didn't watch part 1, go ahead and watch that. It shows the animation of how the secant line turns into the tangent line. So now we got to think about something. How do I calculate the slope of this line? Okay, and I'm going to come over here and I'm going to call this the slope of the tangent line. Now remember what we had to do. We had to shrink h and have h approach 0. That distance needed to approach 0. So wait a second here. Wait a minute. Have we already talked for 2.5 weeks about values approaching other values? Have we been talking for a while about as x approaches 1 or h approaches 0 or something approaches a number? Have we been talking about that? And the answer is yes, we have. And what we've been doing is we've been using a limit. So if I were to take the limit as h approaches 0 of my difference quotient of f of x plus h minus f of x all over h, then what we end up getting here, folks, is we end up getting this thing called the derivative. And I'm going to call that f prime of x for right now. Okay, we'll name this a number of things, but This is called the derivative, okay? And this is the fundamental, one of the fundamental things that we are doing in calculus, okay? Which is really exciting, okay? So this is the derivative, all right? And the derivative, and I'm going to say this, okay? I'm going to write this, and this is something I want you to memorize, okay? The derivative is a function. The derivative is a function that generates the slope of the tangent line, at any x value. Okay? And that's just my way of saying what the derivative is in layman's terms. The derivative, and that's what it does. The derivative is a function that generates the slope of the tangent line at any x value. Okay, folks, this is very confusing for you. I know. Maybe it makes sense, maybe it doesn't. But we're going to do a bunch of examples on what this is and what we're actually doing here. We're going to work a lot in class on what a derivative is. We'll look at graphs of derivatives, but we end up getting a function. Okay, that's what our plan is, and that function will generate the slope of the tangent line at any x value. So I'm going to go ahead and stop this video because the next 4 problems are fairly involved and they require a fair amount of work. So what I want you to do is just go ahead and watch this, take notes, and then we'll just watch the next one.